Welcome to Data Science 1, Probability. Here we're going to talk about relative frequency today. Okay, so from our previous videos, you know what a sample space S is and what events are. Now what we want to do is, how do we assign a probability to some event E? So we're going to denote this P of E. One way to do this is what's called the empirical approach, is also called relative frequency, which looks at the proportion of the time that the event was observed. Okay, so we just go out, conduct the experiment a whole bunch of times. We looked at the number of times that we see our outcome E that we're interested in, or event E that we're interested in, and we just create a proportion out of it. Now here we're going to use a hat on our little P here, just so that we show that it's estimated from some data. So let's go to our example of Lionel Messi, and let's watch him attempt some goals and see how many times he makes them.
Their second goal. Great header. Lionel Messi!
They have this prodigious home record. Oh. Messi finds the gap where there wasn't one. Oh.
Best defensive stats as well. Here's Lionel Messi. Oh, wonderful. Absolutely. But he'll keep plugging away. Lionel Messi is destroyed. Better defenses than this. Messi! Oh.
Great ball.
Just to the edge of the arc, Messi shows, pulls it back, and then fight.
Messi's made a brilliant run. Messi controls. There are several options. He went for the wonder goal.
Slide rule pass, Messi onside. And Messi.
Free kick is a missed swipe from Alves. Now Messi flicks it in. Oh, wonderful.
All right, so we have our sample space, goal, no goal, and we've looked for the event goal. Let's see how to work this out. So we've observed an outcome of 10 experiments. He took 10 shots, and we observed that he made, this is the number of times the event occurred, 3 goals. Hence, we have an empirical probability of, use our formula, 3, which is number of times it occurred, over 10, number of shots he took, which is 0.3. Is his goal completion rate really 0.3? Well, what we can do is we can go back in history and look. So here we can see how he fared in the Spanish La Liga League. All right, so here's what we have across the seasons that he played. Here's the goals he had, and this is the number of shots he took. So he had a total across the Spanish La Liga League of 194 goals out of 759 times. And if you want to get this data, go to this URL here. It'll give you the data that you need so you can verify that these are correct. All right, using this new information, we have N is 759 experiments. That's how many shots he took. And he made 194 of them, which were goals. That's the event we're looking for. So it's 194 over 759, which is approximately 0.2555. Okay, so there's a approximately 0.2555 probability of Lionel Messi scoring a goal when he takes a shot. So this is pretty easy to do. All right, so let's look at a fishing example. What's the probability of catching a fish when using a net? Okay, so we're going to cast a net. You've probably seen this before. And our event is whether there's a fish in there or not. Doesn't matter how many fish. It could be 20 fish. It can be 1 fish or no fish. All right, so let's see how often we need to see this happen. We need to see it from many casts. So he keeps casting and casting and casting. And we would need to see the outcomes from all of these. So the problems with empirical probability, also known as relative frequency, is, or it's not a problem, it is an intuitive approach, right? You just watch and see what happens. But it's quite expensive, and it has other problems. So number one, it takes time to watch each of these experiments. While you're watching soccer, you might say it's great, but 759 goal shots across how many years was that? That took a long time to collect that information. It's not as easy as just looking everything up on the internet. Okay, some experiments are difficult to conduct. Okay, they're really, really, really expensive to conduct some experiments. So we have to be careful when we do that so that, number one, we take care of people. For example, if an experiment is on a person, then we may not be able to do this type of thing. That's what I mean by difficult to conduct, because it may be unethical. Okay. Another problem is rare events take even longer. Think about volcano eruptions. What's the probability that a specific volcano erupts today? Well, some of volcanoes, we actually haven't ever watched them erupt. We know they're active, but we have no actual record of exactly which day it erupted. So these probabilities are hard to estimate. Now, one thing that does bail us out is the probability becomes more accurate as the number of experiments increase. And this is the idea of the law of large numbers, and we'll talk about this more later. But it basically says our empirical probability, or relative frequency, gets really, really close to the true probability the more experiments we conduct. So if we can do lots of experiments, like in a computer, that would be great. Because then we can see what happens, and we just get lots and lots and lots of experiments and see what the outcome is. All right, so we've looked at this relative frequency approach, and it's one way to assign probabilities to events. It can be expensive, it can be difficult. However, it may be the only way to estimate the probability of some event. So what if we could come up with a way to estimate a probability without the need to conduct an experiment? What if we could just think about it and use logic to come up with lots of ways to conduct an experiment and get the answer without actually having to spend any money on it? And we'll start talking about that in the next video. See you there.